today I will tell you about clean code. What is it? How to make it? How to create it? And today we will look at three main topics. I will tell you about naming, how to choose clear and meaningful names, about methods, how to write short and focused methods and functions, and about comments, when to write comments and when not to. Of course, I will create the table with results for you, maybe today or tomorrow. And here on this slide, you can see a little funny image with very simple rule. The worst code we can find if we hear a lot of what the, another word. And our goal with clean code is to keep the what the per minute as low as possible. And first question is for you. Please tell me, please think a little, how do you think what code is clean? What does it mean?
If it is readable.
Yes, I agree with you.
I think also the code is neat with less comments. Have more like spaces between functions, so that we can easily understand what we are executing this code for.
Very good.
Like using the voice code rule for the good refactoring, and also like for using the performance of the code too, like how neat and what type of functions we use, making the performance of the code we it will have less time complexity and all.
Okay.
Can we say that also extra spacing?
What?
Like if our code is contains lots of space, unnecessary space, then I think it's not clean.
Oh yeah. Okay.
I think you hear me?
Yes.
Like for clean code to be elegant and efficient, and the logic should be straightforward.
Yes. Okay.
I
Maybe.
think clean code is really like easy to read, understand, and maintain. Yeah, it's hard. It's not.
Okay. I see that you understand what is it, and it's great because you already have some feeling about what code is clean. And let me show you the opinion about this question from some famous guys. For example, Björn Strostrup, it's an inventor of C++ language. I know that some of you like this language. And he thinks that clean code should be elegant and efficient. Then Grady Butch, it's author of one very famous books, thinks that clean code should be simple and or it's like well written prose. I think it's something the same which you already said, and it's very good. The author of book Good Code, Bad Code, Tom Long, think that good code should work, continue to work, even if we change some requirements or add some new features. Then it must be adaptable again, yes, for changing requirements. But we should think that we should not reinvent the wheel. If we already have some solution for some problem, it's better to reuse this solution and not to create something new. Writing clean code is not so easy as someone can think. It takes theory, knowing the rules, and a practice, like writing a lot of code. Sometimes manager in your team protects the deadlines and features. That's why manager does not understand why it's so important to create clean code. And developer protects the code quality. That's why you should think about the quality of your code every time. If we submit bad code just to finish faster, I think that it's not professional. Clean code is our responsibility, and I think every good developer should always remember about it. Why we need clean code? In this slide, you can see some rule, and clean code improves the scalability and maintainability of your code base. That's why it's so important. When we work with someone else's code, we try to understand it and what information we use usually. First of all, we look at the names of functions, classes, variables, maybe folders in your project structure. Then we check the data types, what goes in and what comes out in our methods. If that's not enough, we read the comments or documentations, but I think usually programmers are too lazy to do it. That's why the names of objects and the data types, it's very important. Sometimes we can ask the author of the code in chat, for example, but I think usually we don't do it. And we can dig into the code line by line, but sometimes we are so lazy. That's why it's the naming is very important. And about meaningful names, what is it? Good names are very important in clean code. They help us understand the code without reading every detail. A good name shows the intention of the developer, what developer trying to do. When you create something new, and you should create the name for your object, for your variable, method, or class, you should ask yourself 3 questions about this object. Why does this thing exist? What does it do? How is it used? If name answers these questions, it's a very good name. If you need to write a command to explain what a name means, it means that the name is not clear enough. Bad names slow down everyone who reads the code, and good names make code easy to read, easy to change, and easy to review. Let's check some examples. When you create your code in the first year of university, very often you created something like this. But I hope you understand that what is a D? We can have a lot of variants. And if we try to use more words in this name, we can have something like this. We have a lot of variants, and very important to explain the meaning of your variable in the name of this variable. Then, another example. Here I have a little piece of code, and this code is from one very famous game. Maybe you have some ideas what logic from what game we can find here in this method. I think you have not ideas. But what we will get if we will change the naming of this method? Look to the bottom of this slide, think a little, and maybe someone have the idea what is the game.
Chess?
What?
Chess?
No. Game of life.
What was the question mainly?
What is the game in this method?
Is it the game of the Windows
Yes.
1 and 0? You this numbers you click.
Maybe no.
Like there's flags, and you click.
Maybe we have problems because no one remember how this game goes.
Minesweeper?
Yes, you
Like
are
that-
absolutely right. Yes, it's Minesweeper. And I hope you understand that when we have correct naming in our code, it's more simpler to understand the logic of this and understand the domain with only 1, 2, 3, 4, 5 lines of code. Okay, let's continue. We must also avoid misleading names. A bad name can give us wrong information, like in this example with account list, and that is worse than no information at all. For example, with account list, sometimes it's normal to create this name, but maybe it's not a list. A list, it's a special interface in Java, for example. And if you create something in Java and name your variable like account list, but use not list, but array, for example, it's or maybe it's a map or a set that creates confusion and bugs because another developer waits that here he have the list, but it's not the list. Another example with hidden differences in names, using abbreviations that are not clear or used differently in other places. It's very hard to understand it. It's very hard to find the differences, and it's not so good. These names are very long, very similar, but they do different things. It's easy to mix them up. This leads to mistakes and wasted time. Another questions: if we use some special symbols like L symbol or 0 or O symbol in like a name of your variable, it's very hard to read and determine what is it. It's O or 0. And in this screenshot, sorry, it's a dark screenshot because it's a screenshot from my student, and this student work in some famous company, and it's a real code from a real very famous application, but I cannot tell you what is it. But here we have example when we have type feature registry mock and type feature registries mock in one application, and it's very hard to find something if we will have the problems especially in this case when feature registry mock and feature registries mock have the same interface. It means that when we, if we use not correct type, it will be very hard to understand it because they have the same interface, and compiler will not show us that we have problem here. Another examples. Good names should have meaningful differences, not just small changes like in previous slide. Look at these names, please. Get active account, get active accounts. They look very similar, but they do different things. Then this can confuse developers and cause mistakes. Also avoid using generic terms like data, info, like information, object, variable, or some kind of variant of class word. They don't help the reader to understand the purpose of your code. And another little rule: don't use articles in names like the account or something else. They just make the name longer without any meaning. Instead, use a clear naming convention in your team or project. Some teams, some companies have their own naming convention, and it means that you should use it. If your company has not any convention, you can use the naming convention from your stack of technologies or from your language. For example, Kotlin has a special naming convention, Swift has it, C# has naming conventions. Then it means that you can use them. Another example, when we in a first piece of code, here we use some short variant of the word, and it's very hard to pronunciate it. But sometimes you need to explain your colleague some problem with your voice, and it's very hard to read these names. So use the full version of every word, like generation timestamp. Another example, choose searchable names. Very short names like A, X, K, or something else are hard to find in large code base. If you search something like X, you'll probably find hundreds of results, and most of them not helpful. But name should be long enough to be easy to find and easy to recognize. Also, the length of the name should match its scope. If you use some variable just like stepper in your loop, like I, G, K, or something else, of course it should be very short. In some loops you can use these short variables. It's normal because we don't need to find these variables in our code base. For what we try to find them? But if you use some constant which can be used in whole of your project, of course the name should be very long and understandable, like work days per week, number of tasks, and another example. Then use meaningful names, not names based on old coding rules. A lot of years ago we had some coding rules and coding schemes with adding M, P for parameters, I for interfaces, imp for implementations, and another. It was because of constraints of our IDE, because some code we wrote in very simple applications without any coloring of syntax. But now we have it. Modern code editors show type and scopes clearly with colors, with some comments, so we don't need to put that in the name. Of course, one I forgot the word. Exception. One exception of this rule: if you use some architecture, like for example clean architecture, and you have the rule that you have interfaces and you have implementations, and the name of this implementation should be something like this class implementation with imp in the end of your name of your class. Of course, you can use it if it's a rule for your architecture or for your stack of instruments, of technologies, of course. But by default, we should not use these coding schemes. The next. Names should match the kind of thing they describe. Classes are usually nouns with some combinations, but it's better to avoid some words like manager, processor, data, or info, because these words say very little about what the class actually does. Of course, if in your company or in your team you have some rules about this class should be named like manager, this class should be named like data, you should use these rules. But by default, every person has different things about what is manager, what is processor. It means that you can have some trash in your project because you create manager, but your colleague thinks that it should name like controller, and it will be very terrible, I think. Methods should be verbs or verb phrases because they present actions. For example, post something, delete, send email, and etc. This makes the code more natural to read, like instructions. Also, be careful with overloading constructors. Constructors with the same name but different arguments can be confusing. That's why, like in my example, that's why it's better to use factory methods. They explain what is happening and what the arguments mean. You just create static factory methods with readable name, and every developer will understand that here it's necessary to send real number, here it's necessary to send string, and another. Use one word for each concept in your database. When we create our code, it's not some place in which we need to show how we can use every English words. That's why not fetch, retrieve, or just get. Not manager, controller, just use some variant of this word. Also, use names from the solution space, from programming especially. If you create some pattern like visitor, fabric, or observer, or something else, use this name as the part of name of your class, because another developer will understand what is it more faster if he or she knows what is visitor or cure or array or something else. Then, for business logic, use names from the problem space. Use domain names. This helps non-developers, like product owners, for example, understand the system. Also, try to add meaningful context to your names, but don't overdo it. It means that use something like user state, but not just state, but without my super duper app user state very famous blah blah blah. That's too much. Keep names clear, focused, and just detailed enough to avoid confusion. Maybe you have some questions about naming, or maybe some examples. No. Okay, let's continue with the second part, and it's methods. And again, I will ask you, how do you think, how much lines of code should the method have?
Not more than 20.
Maybe. Another opinions? Maximum 100. Maybe.
Actually, it depends, how the program will be. It can be less than 100, or maybe it can even go more to 200 or 300.
But we can separate the method.
Yes. And so that's why, like, it depends. It can be even less than 100.
In chat, I have message. I think maximum 40, maybe.
Like, for
I
example,
think it should be
for many method in a different file. Maybe in a file, it can be like, for example, 20 lines of code. If the code is clear and we use like less functions, and which can also use the same performance and correctness of the code. So yeah, 20 lines of code is enough.
Okay.
I think it should be 5 to 15 per function.
Okay. So it's a very famous question, and we can find a lot of articles about it in the internet. And in books, I found the research results about it, some statistic about how the quality of our code depends from the number of lines. And this is a slide with some conclusion. The authors of books about refactoring have different opinions. For example, McConnell thinks that no more than 1 or 200 lines. Fowler thinks that up to 10 lines, ideally from 1 to 5. I think it's too much because we will have a lot of very short methods, and I think it's very hard to understand them. Martin thinks up to 20. Sometimes in online I can find some opinion that how much will fit on the screen, and 10 or 15 years ago it was the most popular opinion, because you maybe don't remember you were a child, but I remember that we had very not so little, but little monitors and with the same size, like 15 or 17 inches, and it was normal to count the size of methods with size of screen, because all developers have the same size of screen. But now we have a lot of variants. Someone work with 2 monitors, someone select such a very monitors with very big width. That's why this metric is not so good. Here on this slide, you can see the chart, how lines of code, how time for adding some new line depends from lines of code already written in your code blocks. So my opinion that from 20 to 100, and it depends from code style, it depends from the problem which we try to solve with this code, because sometimes we need to create some very hard algorithm like you created in eJudge in first year. Sometimes we need just to read something, copy it, and it's very simple. Why I need to separate it into some little functions if if this logic is very simple. There is no single rule, but our goal is clear: one method, one task. If the method does too much, it should be separated into little steps. A good method does only one thing. I does not mean the one line of code. It's about one operation. It must do one operation, do it well, and do nothing else. If a method tries to do many things, it becomes hard to understand, hard to test, and hard to reuse. This is one of the most important rules in clean code. One method, one responsibility. If you can't describe what the method does in one short sentence, it probably does too much. And we need to split this method into some little methods. About arguments or parameters of our method. The fewer, the better. The best method has no arguments, but I understand that reality works in another way. That's why from 1 to 3 parameters in one method, it's okay. More than that, and some problems begin. You add more variables to your code, and in previous lecture I already told you that we can think only about not more than 7 variables in one time in our brain. Testing becomes harder. Understanding that the method does takes more time. And output arguments. I hope you remember what is it. It's where the method change what you pass in. You pass something like a parameter and your method change this value. It's almost a bad idea because output arguments create confusion and unexpected side effects. And the worst of all, argument flags, like is necessary to continue equals true. This means the method does two things depending on the flag. That breaks the single responsibility principle of Solid. I hope you remember it. That's why we need to avoid arguments flags. Then, when several methods use similar parameters, it's better to pass them in a consistent way. For example, if you have a lot of methods which use like parameters name and surname of person, please always pass them with first name, second name. If you will change this order in some method, you will have the error because some developer will send these two variables in the old order, and compiler can't find this problem because we have just two strings. Compiler does not understand what's the problem. So pass them in a consistent manner. Also, use all parameters your pass. If a parameter is not used, remove it. Unused parameters confuse readers and make testing harder. And never use method parameters as work variables, like in this example. Don't change them inside the method to store temporary values. It makes the code harder to follow and can cause unexpected bugs. Parameters should stay clean and predictable, just inputs and nothing more. Another idea about methods, it's side effects in method. And here you need to read this code. Side effect is when a method does something outside its main purpose. And here I have a method check password, and inside it I have a side effect. Please read it attentively, and maybe you will find this side effect. Okay, let me help you. Please check the name of this function and the actions inside these functions. Yes, in chat I have the correct answer. Session dot initialize. You are absolutely right. It's very good. Here in this function, we need to check password, and we have the username and password. But why we have the code session initialize? We just need to check password, and that's all. It can be the cause of problems because if another developer who does not know what we have inside this function just use it, of course he or she will run something like check password, and if it's true, after that he or she will run session initialize. But we already have initialized session, and we will not understand why it's problem, why we have two sessions in the same time. I think it's a very bad idea. That's why we need to create such methods without any side effects inside it. Another examples of side effects, it's a changing of global variable, for example. It's writing to file, update of database, modify input arguments. These actions are called side effects because they are not the main result of the method, but they still affect the system. Side effects make code harder to test, harder to understand, and harder to reuse. That's why clean methods should avoid side effects or make them very clear when they are needed. For example, here, if we can't to change and remove session initialize from this method, we need to add information about it to the name of the method, like check password and initialize session if true, something like this. But of course, it's violation of single responsibility principle. So it's not so good. Then, here are some more important rules for writing clean methods. We need to separate commands and queries. A method should either do something or answer something, but not both. Remember about single responsibility. For example, save user saves a user. It should not also return a boolean like true or false. If a method change state, it should not return data. Another rule, it's use exception instead of error code, because it's very simple to lost error code somewhere in your system, but exception, it's thing which we must work with it. Returning errors codes mixes business logic with error handling. That's why exceptions keep the code cleaner and easier to follow. It's better to isolate try-catch blocks and don't wrap entire method in try-catch. Only catch exceptions around the code that might fail. This keeps the method readable and focused. And it's better to handle errors as one clear operations because error handling logic should not be spread across the code. It's better to keep it in one place and we will have the code which clean and easy to test. Good methods do one thing well, handle errors clearly and never mix responsibilities. Do you have some questions or examples or stories about methods? No. Okay. But again, with little question to you. Comments. Please tell me, do you use it? And when and why?
We use it sometimes for like explain what this function do.
Mm-hmm.
Just to give more explanation for something, for some methods, or maybe some classes.
Okay. I use it too, but it's necessary to remember about rules, how we can use them. So, command is a sign of failure because if we have the code which requires the command, it means that this code is not so readable, and it's better to just refactor this code and make it more readable. Why? Because so often developers cannot normally support comments. We are too lazy to do it. And let me show you a little example. This is a example from one application, and here we have function with name load current city and comment saving current city. And I think it's confusing because I don't understand what this function do, because comment does not match the name of this function. Why it happened, I don't know. Maybe some developer renamed this function and forgot to change the comment. It's we can find it in history, but now I have a problem with this method because I don't know how to use it. And it's necessary to open the source code of this function and find what this function do. It takes a lot of time. I don't want to do it. I'm too lazy to do it. That's why the comment should match the goal of the function. So inaccurate comments much more harmful than their absence. If here I have not any comments, just load current city, I will not have the questions. But with this comment, I have a questions because I don't understand. So the code is the only source of correct information. That's why it's better to make your code clean and readable and use correct naming. And in this situation, we don't need any comments. And if you see the code that requires comment, it's better to rewrite it. But we have some exceptions. Let me show the examples of good comments when we need to use them. Not all comments are bad. Some comments are useful and even necessary. For example, legal comments. It's a comments about license agreements or something else. And I think we need it because we need to know how we can use this code. Some informative comments, this explain things that are not obvious from the code itself. For example, regular expression. I hate regular expression, to tell you the truth, because it's very hard to understand what this expression does without spending a lot of time to understand it, to read it. And here, comment will help me to understand it very fast. Just it's a time. Okay, everything is clear. Another example, it's a presentation of intent. These comments explain why something is done, not just what is done. Why? We need to know it. They help the reader understand the reasoning behind a piece of code. Because sometimes we can see on some code and don't understand why, who is the author of this trash and why it exists. But for example, here we have explanation that it's a best attempt. Okay, so it's clear. Another example, it's a clarification. When we want to explain some meaning of something that might not be obvious at first glance. This comment here don't explain how the method works because the code does that, but they help the reader understand what's being tested at a glance. Equal, not equal, greater than, less than, and etc. This is useful when checking lots of similar test cases. It saves times and avoids mistakes. So when comments clarify intent or meaning, they are helpful, especially for testing case. Another good comments example, it's impact alerts. They warn us that the code might be slow, risky, or expensive to run. This type of comment is informal but a bit funny. And intent is clear. This operation is slow or resource heavy. That's why we will not run this test. And another example, I think it's last example of good comments, but we should use them very care because to do comments, it's notes about things that should be done later. They can be useful, but only if they are clear, actionable, and actually followed up. We don't need to leave to do in the code. And now, usually when we try to commit the code with to do inside it, we will have problems with our Git. And it's very good because Git requires to solve all to do commands. Then some importance commands. Sometimes developers write comments like this comment explain why something matters, and that's good. But instead of writing it in a comment, it's better to express it in a code. So this strange code, we can move to new method and add this information like the name of the method. Maybe it will be some strange because it will be very long, but sometimes we just can to replace the bad code with a new function with good name. Then examples of bad comments. Not all comments help. Some actually make the code worse. Let's look at two types of bad comments. First of all, it's mumble comments. It's comments where the meaning is unclear, only makes sense to the author of this code, like in this situation. This does not help anyone. It's confusing and useless without extra context. If a command does not make sense to someone else, it should not be there. Then excessive comments. These comments just repeat what the code already says. And sometimes I spend more time to read this comment than read the code. So too many comments like this make it harder to spot useful ones. Good code should be clear enough that you don't need comments like this. Then another example, a comment that repeats exactly what the code already says. This comment adds no new information, and I think we can remove it. But one exception from this rule. Sometimes we create libraries, and in library every method should have the comment, even if this method is too simple, because we will create documentation for this library automatically. That's why we need to add such comment here, but it's in its exception, only for libraries. Then another examples of bad comments. First of all, it's positioning. It's some kind of visual dividers, and they may look nice at first, but they don't scale. They create noise and break the flow of reading code. And of course, here we have exception too. For example, in Xcode, it's IDE for Apple developers, we have this type of comments like positioning, but when we create such comments, we will, not we, but Xcode will create the dividers in the structure of our file. That's why it's a special instrument of developers, and we often use it, because it make our code more readable with beautiful dividers in the structure. But if your IDE does not have such instrument, you don't need to use these positioning comments. The next example, it's trailing brackets comments. Sometimes it's helpful in a deeply nested code, but usually unnecessary. It's better to add comment before the code, not after, because you already read this code and only after that you see the comment to it. I think it's not useful. And about links to authors, it's better to remove them, because we have this information in Git. Why we need to save it in the code, even if it's just a comment? For example, in iOS development, Xcode create automatically the author of the file like a comment in the start of the file, but we often remove it just because it's a trash. We don't need it. We have this information in a version control system. And commented code, it's better to remove. If the code is needed, keep it. If not, delete it, because we have all code history in version control system. It remembers everything. That's why it's better to remove commented code, because when we have commented code inside our code base, it can confuse, because I don't understand why this code commented. Is it works or not? Is it bad code, or what does happen with this code? What I need to do? I need to change it. I need to check it. I need to remove it. A lot of questions. I don't want to solve all these questions. That's why it's better to remove code if we don't need it. And this slide, it's a little summary about work with comments. And this is the last slide in this lesson. Maybe you have any questions about the topic of our lesson.
No, I guess it's clear.
Great. I think it's clear, it's simple, but it's very important to remember about it, because we always think that it's clear, and that's why we don't forget and create very terrible code.